Good evening, am I audible? Am I audible? Please reply me in the chat box. We have waited long for others to come, but they yet to come, so we'll start.
Okay, sir.
Am I audible, Joseph?
Yes, sir.
Okay. Here, okay, in the last class, uh, we have seen formulae, we have seen how to apply those formula, we have seen some rules, are given some tricks to remember the formula, right?
Sir.
So in this lecture, I'm directly start with the okay numericals. In the last class, did we do any numericals? Like, did we do any numericals in the last class?
No, sir.
Yes, I've done some numericals. No? So what was the last
No,
topic which
sir.
we did? Was it polar and Cartesian coordinates?
Yes, sir.
Polar and Cartesian coordinates was the last one. Okay, so I'll do some few numericals just to understand how to apply the rules, and then I'll start with the advanced numericals. So I guess I did polar coordinate system in the last class. So Cartesian to polar and polar to Cartesian. If you remember, we had found out the relation x is equal to r cos theta and y is equal to r sin theta. Okay, and we also found out r is equal to under root of x square plus y square and tan of theta from here can be written as y by x. So this is to convert it into Cartesian, this is to convert it into polar. In Cartesian system, the location of the point is given by x comma y, whereas in polar system, the location is given as r comma theta. So suppose I've been given that r comma theta is equal to say 1 comma 30 degrees. I have to find out the Cartesian coordinates, the values of x and y. So I just put over here x is equal to 1 and the cos of 30 is to 1 into sin of 30. Cos 30 is root 3 by 2, whereas sin 30 is 1 by 2. Okay, so I get x comma y is equals to root 3 by 2 comma 1 by 2. So I was being given the polar coordinates as 1 comma 30 degree and I found out the Cartesian coordinates of that. Similarly, suppose we've been given with Cartesian coordinates when I want to find out the polar coordinates. So that can also be done. Suppose say x comma y, okay, 3 comma 3. Okay, then I will use this. I want to write it in polar form, so I will use r as equals to under root of x square plus y square. So that will be 3 square plus 3 square, so that will be 9 plus 9, which is 18, which can be written as 9 into 2. Hence I'll get r as equal to 3 root 6. Similarly, theta, tan of theta is part of x. So I write tan of theta is equal to y, that is 3, and x, that is also 3. Therefore, I get tan of theta is equal to 1. And as per the table, okay, when do we get tan of theta as 1? When it is tan of 45 degrees. So tan gets cut and we get theta is equal to 45 degrees. Therefore, I can represent r comma theta is equals to 3 root 2 comma 45 degrees. This is what we had seen in the last class, conversion of polar to Cartesian, Cartesian to polar. Okay, so in that case, I was given in polar form, I converted into Cartesian form. I was given into Cartesian form, I converted into polar form. We'll see some more preliminary 2-3 sums and then we'll go to the advanced numericals. Okay, please take the screenshot of this. I'm going to rub it. Please take the screenshot of this. I hope everyone is taking a screenshot. Okay, suppose I want to find out the value of cos of 15 degrees. I want to find out the value of tan of 15 pi by 12. I want to find out the value of sine of 495 degrees. Suppose I want to find out the value of cos of 930 degrees. So let's see how do we apply the rule when we get this value. So first let us see cos of 15 degrees. So the standard table what we have is for 0 degree, 30 degree, 45 degree, okay, then 60 degree and 90 degree. Then all the other values can be found out by using this only, so there is no need to buy out any other values. So this 15 degree can be written as cos of 45 degree minus 30 degree, right? 15, 45 minus 30 is nothing but 15. So instead of 15 I wrote 45 minus 30. Now in the last class we have already seen the formula. Formula of cos x minus y can be written as cos x into cos y plus sin x into sin y. Therefore this can be written as cos x into cos y. If it is minus then it will come plus sin x into sin y. Therefore, cos of 15 degrees is equal to cos 45 is 1 by root 2 and cos of 30 degree is root 3 by 2. Sin of 45 degree is 1 by root 2 and sin of 30 degree is 1 upon 2. So I get cos of 15 degree is equal to the denominator is same to root 2, so no need to equalize the denominator. So root 3 plus 1 upon 2 root 2. So this is the value of cos of 15 degree. Next, I need to find out the value of 13 pi by 12. Okay, I need to find out the value of 13 pi by 12. So first, let me find out how much is 13 pi by 12. So, no need to again remember or by the formula for radian to degree or degree to radian. Just remember one simple thing. Pi is 180 degree. So pi can be written as 180 degree over here. So 6 2s are, 6 3s are, 2 1s are, 2 15s are. Okay, so that is 15 into 13. So that is how much? 15 into 13. So that will be how much? 150 45. Okay, 195 degrees. Right, 15 into 13 I have not calculated. You guys can calculate and let me know how much is 15 into 13 and then we'll find out the value of 30 tan of 13 pi by 12. So answer me, how much is 15 into 13? Correct, 195? Okay. So tan of 13 pi by 12 is nothing but equal to tan of 195 degrees. Which can be written as tan of 13 pi by 12 is nothing but equal to 180 degree means pi plus 15 degree. If you remember, we have written a formula whenever it is pi plus minus theta ratio. Next, pi plus theta. When you do pi plus theta, it goes in the third quadrant. In third quadrant, my tan is positive, and therefore this will be positive. And tan of pi plus theta will give me tan theta, so that will be tan of 15 degrees. Therefore, tan of 13 pi by 12 is nothing but equal to tan of 15 degrees. So, like last time, I can write in the same way. Therefore, tan of 13 pi by 12 is equal to tan of 15 degrees, which can be written as 45 minus 30 degrees. So, tan of x minus y is tan x minus tan y, tan x minus tan y upon 1 plus tan x into tan of y. Therefore, tan of 13 pi by 12 is equal to tan of 45 is how much? 1. Tan of 20 degrees is how much? If you don't remember, it's okay. Just remember that sin by the sin 30 is 1 by 2, cos 30 is root 3 by 2. So 2 gets cut. Then get 1 by root 3. 1 plus 1 into 1 by root 3. So I'll equalize the denominator, so I'll get root 3 minus 1 the whole by root 3, and here also root 3 plus 1 the whole by root 3. So root 3 gets cancelled, therefore I get tan of 13 pi by 12 is equal to root 3 minus 1 upon root 3 plus 1. Which we have learned in the last class, and the rule, okay, by applying that we can find out the values. Please take the screenshot of this. I hope everyone has taken the screenshot. Okay, let's go for the next. Sine of 495 degrees and cos of 930 degrees. So, sine of 495 degrees can be written as sine of 360 plus, so 495 minus 360, so that is 5, 9 minus 6, that is 3 and 137. See, why I think like this? Because I don't know how much it is. So I can always do 360 degree means one circle. So after one rotation, it is how much? And that is why I've broken it up as 360 plus something. So I can write it as 360 is nothing but 2 pi. So 2 pi plus 135 degrees. So 2 pi means one rotation. After one rotation, if I just add certain angle, so I will reach in which quadrant? I will reach in the first quadrant. In first quadrant, sine is positive. Therefore, I write plus sine of theta. So theta is how much? 135. So I write sine of 135. So sine of 495 is equal to, okay, sine of 135. Therefore, sine of 495 is equal to sine of, further I don't know the value of 195. So I can write 135 as 90 degree plus 45 degree in the known value. So 135 can further be broken as 90 plus 45. So when I do 90 plus 45, I will reach in the second quadrant. Then second quadrant sign is positive, so plus, and here 90 means pi by 2. Whenever this pi by 2 plus minus theta ratio changes to co-ratio, the sign will change into cos. So it is cos of 45 degrees. Therefore, sine of 495 is equal to cos of 45 degrees, and cos of 45 is how much? 1 by root 6. Therefore, sine of 495 degree is nothing but equal to 1 by root 6. Similarly, let's find out cos of 930 degrees. So again, one circle means 2 pi, that is 360 degrees. So if I am rotating 2 times, so 360 into 2, that is 720 degrees. What I am doing is 930 minus 720. So 0, 1, 2. So therefore, I can write it as cos of 720 plus 210 degrees. So that will give me cos of 2 pi plus 210 degrees. So 2 pi plus theta will give me first quadrant, and first quadrant all are positive, so I will positive cos of 210 degrees. Why? Because whenever it is pi plus minus theta, ratio remains same. So I get cos of 930 degrees, nothing but equal to cos of 210 degrees. Further, it can be written as cos of 180 plus 30 degrees. 180 is nothing but pi, so this will become cos of pi plus 30 degrees. So when I do 180 plus 30 degree, in which quadrant I will reach? I will reach in third quadrant. In third quadrant, only tan and cot are positive. Therefore, cos of 930 degrees is nothing but this is cos 30 degree negative, and whenever it is pi plus minus theta, ratio remains same. So this will be minus cos of 30 degrees, which is minus value of cos 30 is how much? Root 3 by 2. Therefore, I get cos of 930 degrees is equal to minus root 3 by 2. This is how I can apply the principle and find out the value. Please take the screenshot. We'll see one or two more numericals and then we'll directly go on to the advanced numericals. Okay? Take the screenshot of this. Okay. I guess everyone is taking the screenshot. Till I rub the board, okay, I am giving you a question. You guys can try it. I have to prove that cos of 24 degrees plus cos of 55 degrees plus cos of 125 degrees plus cos of 204 degrees plus cos of 300 degrees is equals to 1 by 2. We have to prove this. When I add all these values, I get how much? 1 by 2. So till the time I rub the board, you guys can try this numerically. Okay, so let's take the LHS. My LHS is cos of 24 degrees plus cos of 55 degrees plus cos of 125 degrees plus cos of 204 degrees plus cos of 300 degrees. So I am not worried about cos 300 degree because it is going to give me answer in standard angle. If I do 360 minus 60, I get 300. So 360, that is 2 pi, and 60, that is a standard angle. So I need not worry about cos 300 degrees. But if I think about 125, 204, 55 and 24, these are not standard angles. And even by addition or subtraction of any angles, I am not going to get a standard value. Suppose if I take cos of 125 degrees, so that will be 90 plus 35. 90 plus 30 is okay because again 30 is the standard angle, but that is going to give me 35. Similarly to 104, it will be 180 plus 24 degrees. So again, these are not standard angles. So what we will do over here, if we don't have standard angles, so let's not worry every time about converting into standard angles. See if I'm able to get this term and this term. So I've already given you one, this 204 can be written as 180 plus 24. So I can get 24 over there. Similarly, 55. Can I get by using 125? So yes, 180, 180 minus 125 will give me 55. So therefore, I can write LHS is equal to cos of 24 degrees plus cos of 55 degrees plus this cos of 125. 125 can be written as 180 degrees minus 55 degrees. Similarly, plus cos of this 204 degree can be written as 180 degree plus 24 degree plus cos of 300 degree can be written as 360 minus 60. So when I subtract 60 from 360, I'll get 300. So 300 can be written as 360 minus 60. Therefore, I'll get LHS is equal to cos of 24 degree plus cos of 55 degree. Now cos of 180 minus 55. So 180 means pi. Pi minus theta, which means I'm going to reach in the second quadrant. In second quadrant, sine and cosec are positive. And this is cos. So cos will be negative in second quadrant. Hence minus. Next, whenever it is pi plus minus theta, ratio remains same. So this will give me minus cos of 55 degree. Similarly here, cos of 180 plus 24 degrees. So 180 plus 24, I'll reach in the third quadrant. In third quadrant, again tan and cos are positive and this is cos, so cos will be negative. So again minus. Am I audible? Am I audible? Is the
Yes, sir.
board clear? There was an internet problem. Okay, please take the screenshot of this. Take the screenshot of this so that we can go for the next numerical. I hope you have taken the screenshot. Let's do next. Tan of alpha is equal to 1 upon root of x into x square plus x plus 1. Tan of beta is equal to root x upon under root of x square plus x plus 1. And tan of gamma is equal to under root of x raised to minus 3 plus x raised to minus 2 plus x raised to minus 1. And I have to show that it's saying us show that alpha plus beta is equal to gamma. He's saying me to prove that alpha plus beta is equal to gamma if the values of tan alpha, tan beta and tan gamma is same. I need to find out the value of alpha, beta and gamma. But he has given us the values of tan alpha, tan beta and tan gamma. So how to prove it? So suppose if I multiply by tan on both sides, if I multiply by tan on both sides, then what I can get? I can get tan of alpha plus beta is equal to tan gamma. So if I am able to prove this, I will be able to prove the given thing what he has said. That is alpha plus beta plus is equal to gamma. So therefore what I am going to do, first I am going to find out the value of tan of alpha plus beta and I am going to prove it that it is equal to tan of gamma. So tan of alpha plus beta by formula can be written as tan alpha plus tan of beta upon 1 minus tan of alpha into tan of beta. Remember the formula of tan of x minus y is tan x plus tan y upon 1 minus tan x into tan y. So I have applied that formula. Therefore, tan of alpha plus beta is equal to, the value of tan of alpha is 1 upon root of x into x square plus x plus 1 plus tan of beta, the value of tan of beta is root x upon under root of x square plus x plus 1 divided by 1 minus tan of alpha, that is 1 upon under root of x into x square plus x plus 1 into tan of beta, which is root x upon under root of x square plus x plus 1. Therefore, tan of alpha plus beta is equal to, I can write this as something like this, root x into root of x square plus x plus 1. This both the terms were in multiplication and were in the square root are written in multiplication only, but I have given separate square. So this will help me in simplifying. X upon under root of x square plus x plus 1. The whole upon 1 minus 1 upon this can be split in the same way again, root x into root of x square plus x plus 1 into root x upon root of x square plus x plus 1. So this root x and here root x gets cancelled because it is a multiplication. In this case, I have this term over here to equalize the denominator. I will have to multiply and divide by root x. so that my denominators become equal. So that is what I'm going to do. So I'll get tan of alpha plus beta is equals to, so when I multiply and divide by root x, so root x into root x will give me x. So this will become 1 upon x upon, here the denominator will become root x into root of x square plus x plus 1. The whole upon, in this case, root x into root x, so root x square will get cancelled in this case, I get 1 upon 1 plus x square plus x plus 1. Because this is root and this is root, so root into root, so square root will get cancelled. So I will get 1 upon x square plus x plus 1. This I will get 1 upon 1 plus x upon root x into root of x square plus x plus 1. Whole upon, here I'll equalize the denominator, so I get x square plus x plus 1 minus 1, the whole upon x square plus x plus 1. Here plus 1 and minus 1 get cancelled. So I get tan of alpha plus beta is equal to 1 plus x upon root x into root of x square plus x plus 1, the whole upon, here plus 1 minus 1 got cancelled. Here I have x square plus x, so I can take x common from that, so I will get x plus 1 upon x square plus x plus 1. So this x plus 1, this x plus 1 gets cancelled, this will come down, this will go up, so I will get x square plus x plus 1, the whole upon x into root x into root of x square plus x plus 1. Therefore, I will get tan of alpha plus beta is equal to, x can be written as root x into root x, hence this can be written as root of x square plus x plus 1 into root of x square plus x plus 1. The whole upon x into root x into root of x square plus x plus 1. So this one term gets cancelled. Here I will get root x square plus x plus 1 upon this x, okay, can also be written as root of x the whole square. Because everywhere root is there, so I can write all the terms inside the root. Hence, I have written this x is under root of root x square. So square root and square gets cancelled, so I will get x. So I am right mathematically. Okay. Therefore, I can write tan of alpha plus beta is equal to under root of x square plus x plus 1 upon, this can be written in the same square root sign, so which can be written as x square into x, that is ultimately x. Again, furthermore, both can be written in one square root symbol itself, so x square plus x plus 1 divided by x cube. So I will get under root of x square by x cube plus x by x cube plus 1 by x cube. So x square upon x cube, that will give me 1 by x. So I will get tan of alpha plus beta is equal to under root of 1 by x plus 1 by x square, x upon x cube, that will give me 1 by x square plus 1 by x cube, which can furthermore be written as 1 by x can be written as x raised to minus 1. 1 by x square can be written as x raised to minus 2. 1 by x cube can be written as x raised to minus 3. If we see, it is exactly the value of tan gamma. So I have got tan of alpha plus beta is equal to tan of gamma. So from here I got tan of alpha plus beta is equal to tan of gamma. Which means tan and tan, okay, on equals to both sides will get cancelled. So I will get alpha plus beta is equal to gamma. So this is what he told me to prove. Prove that alpha plus beta is equal to gamma. So I successfully proved alpha plus beta is equal to gamma. take the screenshot, go through the solution. If you have any doubts, then please ask me. Take the screenshot. Done. Okay. Let's go for next. I hope everyone is taking the screenshot. Let's see one more, and after that we'll go for some advanced numericals. To show that under root of 1 plus sine to a and 1 minus sine to a is equal to tan of pi by 4 plus a. So we can start with LHS also, or we can try out with RHS also, or we can solve both half and then we can prove. Let's see what we can do. I'm taking RHS over here. Tan of pi by 4 plus a. So that by formula can be written as tan of pi by 4 plus tan of a upon 1 minus tan of pi by 4 into tan of a. So it can furthermore be written as tan of pi by 4 is 1. So 1 plus tan of a upon 1 minus tan of a. Which can furthermore be written as tan can be written as sine by cos. So sine a by cos a upon 1 minus sine a upon cos a. So I'll equalize the denominators. So I'll get cos a plus sine a the whole upon cos a. Similarly below also I'll get cos a minus sine a the whole upon cos a. So cos a and cos a, this cos a, this cos a will get cancelled. Therefore I'll get RHS is equal to cos a plus sine a upon cos a minus sine a. 1 plus sine to a. Let me leave the RHS over here. Let me take the LHS now. Under root of 1 plus sine to a upon 1 minus sine to a. So first thing, if I see in the RHS of the solving there is no square root. So the first thing which should come in my mind is somehow I have to remove this square root. After that, we'll think how to do. The very first thing what I'm going to do is I will have to remove the square root. So if we remember the formula, sin 2a can be written as 2 times sin a into cos a. And 1 by the identity can be written as sin square theta plus cos square theta is 1. So if I remember, okay, algebra says that a plus b the whole square can be written as a square plus b square plus 2ab. So the similar term I am going to get so that I can remove the square root. So this one I can write it as sin square a plus cos square a plus this sin 2a can be written as 2 times sin a into cos a. We had already written this formula in the last class. Similar, this one also can be written as the same way sin square a plus cos square a minus 2 times sin a into cos a. Therefore, I will get LHS is equal to under root of a square plus b square plus 2ab. So it can be written as a plus b whole square. Second, write it as cos a plus sin a b whole square. Upon similarly here also, okay, a square plus b square minus 2ab. This can be written as a minus b whole square. So now the square and square root will get cancelled here also. The square and square root will get cancelled. So I will get cos a plus sin a upon cos a minus sin a. If I see equation number 1 and 2, isn't it exactly same? I get LHS is equal to RHS. Hence proved. He wanted us to prove this particular thing and we have proved this thing. Okay, what I did is I have solved half RHS, I have solved half LHS, and I have proved that both are nothing but same. Okay, I hope you guys have understood. Take the screenshot. Now we are going to start with the advanced numericals. Taken the screenshot. Okay, I hope everyone has taken the screenshot. The expression tan of a upon 1 minus cos a plus cot a upon 1 minus tan a can be written as option number A sin a plus cos a plus 1, option B, or it is not plus, sin a into cos a plus 1, sec a into cosec a plus 1, option C, tan of a plus cot of a, option D, sec a plus cosec a. So this has come in the year 2013 JEE main. This question has come in 2013 main. So whatever previous numericals I did, I just wrote show that. That is why it became easy. This is also the similar kind of thing only. When I'm saying expression can be written as, it means show that. But here in this case the problem is we don't know what we have to prove. Any of this one can be our option. Okay, and if you see the option is in terms of sec, cosec, tan, cot, and sin and cos also. Now, the sine and cos, okay, can be obtained only if I convert this tan and cot as sine by cos. That is the easiest thing which we can do over here. So, let's try this. So, tan A can be written as sine A by cos A. The whole upon 1 minus cot A can be written as cos A by sine A. Plus, similarly, cot A can be written as cos A by sin A upon 1 minus tan A. Tan A can be written as sin A by cos A. So the next logical step which I am going to do is I'll equalize the denominators. So sin A by cos A the whole upon sin A minus cos A upon sin A. Plus here also cos A by sin A the whole upon cos A minus sin A the whole upon cos A. So this will come below, this will go up, this will come below, this will go up. So sin into sin, that will give me sin square A upon sin A minus cos A into this term came down, that is cos of A. Plus cos A goes up to cos A into cos A gives me cos square A. This sin A term came down, so that is sin A into cos A minus sin A. Now here I have sin A minus cos A, whereas here I have cos A minus sin A. So if I just take a minus sign common, then my denominators will almost become common. So that is what I am going to do. Next is therefore sin square A upon cos A into sin A minus cos A. If I take minus sign common, then plus minus is minus. This will become minus cos square A upon sin A into sin A minus cos A. Okay, this was cos A minus sin A. I took minus sign common, so that is why it became sin A minus cos A. So now these two terms are same, sin A minus cos A, sin A minus cos A. But here I have cos A in multiplication, here I have sin A in multiplication. Therefore, for the denominator to be same, okay, what I will have to do is I will have to multiply, okay, here by cos A and here by sin A. In that pursuit, sin square A into sin A, that will become sin cube A, and cos square A into cos A, that will become cos cube A, the whole upon cos A into sin A minus cos A. Okay, now sin cube minus cos cube, so we'll just remember the formula of this. A cube minus b cube can be written as a minus b into a square plus ab plus b square. Okay, a cube minus b cube can be written as a minus b into a square plus ab plus b square. Therefore, this will become sin a minus cos a into sin square A plus sin A into cos A plus cos square A. The whole upon cos A into sin A minus cos A. So sin A minus cos A, sin A minus cos A gets cancelled. Then this Sine square A plus cos square A. So that will give me 1. Sine square A plus cos square A is 1. So that will become 1 plus sine A into cos A, the whole upon cos A into sine A, which can further be written as 1 upon cos A into sine A plus sine A into cos A upon sine A into cos A. This term is cancelled, so 1 by cos can be written as sec A, 1 by sine can be written as cosec of A, plus this gets cancelled, so I get 1. Am I having this kind of term? Sec A into cosec A plus 1? Yes, I have. Okay, so this came in 2013. So we have got option number B. When we started, we did not knew what we have to prove. We just wrote, okay, everything in terms of sine and cos. That is the best thing to do when we don't know anything. Convert everything in terms of sine and cos. The things will become easy. So everyone, please take the screenshot, and if you have not understood anything, unmute yourself and ask me the doubts. Please take the screenshot. Everyone understood? Everyone is taking a screenshot. Okay. I hope that everyone is taking the screenshot. Let's go for the next numerical. It says that the number of ordered pairs alpha comma beta where alpha and beta belongs to the interval minus pi to pi, satisfying the equation cos of alpha minus beta is equals to 1 and cos of alpha plus beta is equals to 1 by E is. So how many number of ordered pairs I will have? So option A is 0, option B is 1, option C is 2, option D is 4. So when I say ordered pairs means it should be first I will have to write the value of alpha and then I will have to write the value of beta. At the same time, he has given us that the values of alpha and beta should lie only between minus pi to plus pi. So let's solve this. So he has given us cos of alpha plus beta is equal to 1. Sorry, alpha minus beta is equal to 1. So for what value you have 1? Now cos 0 is 1, cos 90 is 0, cos 180 is minus 1 because it is in the third quadrant. Similarly, this is done if I go in the negative direction. So cos 0 after 0, if I go for 90 degrees, so again cos of minus 90 will also be 0 only, and cos of minus pi. So cos of minus theta is cos theta only. So cos of minus pi will be nothing but cos pi only, and cos pi is what? Minus 1. So again we are not getting 1. So 1 we are getting only for one value. What is that? Cos of 0 degree. You know cos of 0 degree is 1. So cos and cos get cancelled. So I get alpha minus beta is equal to 0. So from here I get alpha is equal to beta. Okay. Next, from here, given us cos of alpha plus beta is equal to 1 upon e. Now 1 upon e is somewhat 2.303 something. Okay, e is also a constant. If you must have gone through logarithms, then log of to the base e is called as natural logarithm. Okay, that is called as natural logarithm. So it is, but obviously 2.33, so which means that my 1 upon e will always be less than 1. Because e is 2 point something, it means that this will always be less than 1. So I can say that this equation cos of alpha plus beta is equal to 1 by e satisfies for all values between the range which he has given minus pi to pi. He has given us in the question. But in this case, the equation cos of alpha minus beta is equal to 1 is being satisfied only for alpha is equal to beta. That is only one value. That is happening at, okay, cos of 0 degree. So this is happening only at one place. This is happening in all the places, but this is happening only in one place. And he wants us to find out the ordered pair. And when I want to write the value of alpha and beta, okay, I'm getting alpha is equal to beta. And there is only one value, so there can be only one ordered pair where both the equations get satisfied simultaneously. This equation is getting satisfied for all the values, but this equation is getting satisfied only for one value, that is cos of 0 degree. If I wanted to create an ordered pair of alpha and beta, okay, which is satisfying both the equations, so that I am getting only one, because this equation is satisfied only for one value. Hence, how many number of ordered pairs will be there? Therefore, number of ordered pairs satisfying both the equation is only one. Okay, how many numbers of ordered pairs are there which is satisfying this equation? Is only one. So option is mine. Answer is my option number B. Okay, please take the screenshot of this. Take the screenshot of this. I hope you have understood the numerical. Let's go for the next numerical. given that sine of theta is equal to 1 by 2 and cos of phi is equal to 1 by 3. Then value of theta plus phi belongs to which interval? Option A, pi by 3 to pi by 6. Option B, pi by 2 to 2 pi by 3. Option C, 2 pi by 3 to 5 pi by 6. And option D, 5 pi by 6 to pi. So both theta and phi are acute. If theta and phi are acute angles. So if theta and phi are acute angles and if they are satisfying this value, okay, sine of theta is equal to 1 by 2 and cos of phi is equal to 1 by 3, then the value of theta plus phi will belong to which? Okay, try this. I will solve it, but before that, you guys just try this. Just try this out. I'm giving you 2 minutes. At least try. You will understand how much you are able to catch up. Tried. I hope you guys have at least tried. Okay, trying is important. If you are not getting answer, it's fine. But trying is very important. Okay, let's try to solve this. So sine of theta is 1 by 2. So I can find out the value of theta. So sine 30 degree is 1 by 2. We know that. So I can write instead of 1 by 2. Sine of 30 degree and sine of 30 degree can be written as nothing but pi by 6. The sine gets cancelled, therefore I get theta is equal to pi by 6. We have got the value of theta. Similarly, I get the value of phi, then I'll understand in which of the interval it is going to lie. So cos of phi is equal to 1 by 3. If we see this value, this is not a standard value. Okay, so I will have to multiply the cos inverse on both sides, so I get phi is equal to, if this cos goes over there, it is just written as like this. Cos raised to minus 1, that is read as cos inverse. Don't worry about this symbol. So I get phi is equal to cos inverse of 1 by 3. Now we very well know this 1 by 3 is smaller than 1 by 2 and is greater than 0. Okay, 1 by 3 is smaller than 1 by 2, whereas it is greater than 0. At least we know the values of 0, cos 0, and we know the values of cos of 1 by 2. And that is why I've written something like this. Okay, so 0, when do we get 0? For cos of 90 degrees, which can be written as 5 by 2. Okay, is less than for 1 by 3 if I multiply my cos on all the sides. So suppose if I multiply by cos inverse on all the sides, so this will become cos inverse of 0, cos inverse of 1 by 3, cos inverse of 1 by 2. You don't have to worry about this inverse. Inverse means that which angle you are getting 0. Okay, so you are getting it for pi by 2, so this will be pi by 2 is less than cos inverse of 1 by 3 is nothing but pi. So here instead of cos inverse, I will write pi is less than, when you get 1 by 2, cos of 60 degrees, 1 by 2, 60 degree can be written as pi by 6. But now, when we have written something like this, it becomes that pi by 6 is greater than pi by 2. That is wrong. And hence, we'll just rewrite it as, we will have to change the sign. Okay, so we'll write it as pi by 6 is less than 5 is less than pi by 6. So my value of this phi, this acute angle phi, is greater than pi by 6. Sorry, it is not pi by 6. Sorry, it is pi by 3. 60 degree. 60 degree can be written as pi by 3. It is greater than pi by 3, that is, it is greater than 60 degree, and it is less than 90 degree. The value of phi. Now, he wants us to find out the value of theta plus phi. So I have got this phi, so I'll just add theta. So this will become, if I add theta, I will have to add theta everywhere. So pi by 3 plus theta is less than theta plus phi is less than pi by 2 plus theta. I cannot bring it from the air, right? If I'm adding, so I will have to add on all the sides. So therefore, I will get pi by 3 plus theta. The value of theta is how much? Pi by 6. So pi by 6 is less than theta plus phi is less than pi by 2 plus theta. The value of theta is how much? Pi by 6. If I equalize the denominators, 2 pi plus pi, so that will become 3 pi by 6 is less than theta plus phi is less than, here when I equalize the denominators, 3 pi plus pi, so that will become 4 pi by 6. So 3 1s are 3 2s are. So pi by 2 is less than theta plus phi is less than 2 pi by 3. 2. 2s are 2 3s are. I get the value of theta plus phi is greater than pi by 2 and it is less than 2 pi by 3. Therefore, I can write this theta plus phi belongs to this interval. Since it is greater for open interval, 2 pi by 3. So this is my answer. So which option? Let us see, pi by 2 to pi by 3. Yes, this is option number B. So my answer is option number B. If you are not understanding it any point, then please unmute yourself and ask me. Please take the screenshot of this. Done. Taken the screenshot. Okay. So if you have taken the screenshot, Let's go for the next question. So, which of the following numbers is rational? Which of the following is rational? So, option A is sine of 15 degree. Option B is cos of 15 degree. Option C is sine of 15 degree. Option C is sine of 15 degree into cos of 15 degree. And option D is sine of 15 degree into cos of 75 degree. So which of them is a rational number? So if it should not be in the square root, the easiest way to understand an irrational number is if it is not a perfect square, if it is not a perfect square, then its square root will not be a perfect square, so it will be an irrational number. So all the values which is having those are going to be irrational. So today itself we have found out the value of sine of 15 degree item, which we found out as 45 degree minus 15 degree. And we have got in roots, if you just remember, let's solve so that I don't have any issues with that. So it can be written as sine into cos, so this will be sine 45, sorry, this is 30 degree. 15 degree can be written as 45 minus 30, so sine 45 into cos 30 minus cos 45 into sine 30. So that will give me 1 by root 2 into root 3 by 2 minus 1 by root 2 into 1 by 2. If you remember, you get root 3 minus 1 upon 2 root 2. Similarly, when we started this session, we have found out the value of cos of 15 degree also, and it turned out to be the same, root 3 plus 1 upon 2 root 2. There it is root 3 minus 1 and here. So this is also irrational. Sine of 15 degree is also irrational. Cos of 15 degree is also irrational. Now let's see third option, sine 15 into cos 15. So sine of 15 degree into cos of 15 degree can also be written as 2 by 2 sine of 15 degree into cos of 15 degree. Why did I do this adjustment? Because if you know, 2 sin x into cos x can be written as sine to x, and therefore for that I have adjusted that 2, so I can write 1 by 2 into sine to x. So sine 2 instead of x, what I have 15 degree. So I will have 1 by 2 into 2 into 15, so that is sine of 30 degree. So I get 1 by 2, and sine of 30 degree is also 1 by 2, so I get 1 by 4, which is a rational number. Hence, the answer is option number C. He has asked in the question which of the following is rational. So, option number C is my answer. Sine of 15 degree into cos of 15 degree is going to give me a rational number. So, take the screenshot of this. Take the screenshot. Hope you have taken this screenshot. This was quite easy one. Let's go to the next one. That is 3 into sin x minus cos x the whole raised to 4 plus 6 sin x plus cos x the whole square plus 4 into sin raised to 6x plus cos raised to 6x is equal to. So again, when we solve the numerical, it is in the proof, but it is giving us these options. Option number A is 11. Option number B is 12. Option number C is 13. And option number D is 14. So what is the value of this? 3 sin x minus cos x the whole raised to 4 plus 6 sin x plus cos x the whole square plus 4 sin raised to 6x plus cos raised to 6x. So let's write out first. These terms are very big and it is going to take a lot of space. So I'll break and find out the values and then I'll substitute the values in the given question. Okay. So this is a little bit more complex one. So I'm taking this term sin raised to 6x plus cos raised to 6x. Now this can be written as sin square x the whole cube plus cos square x the whole cube. Right? And now if you have confusions, then you can say let A is equals to sin square x and B is equals to cos square x. So you will not get any confusions. Okay. Therefore, this can be written as A cube sin square x is nothing but A, so it becomes A cube plus B cube. Now A cube plus B cube can be written as, there are two ways of writing. One is it can be written as A plus B into A square minus AB plus B square. Or there is one more way of writing, and how we can write is, if I have A plus B the whole cube, by formula it can be written as A cube plus B cube plus 3A square B plus 3AB square. This is the formula. So from here also I get A cube B cube. So if I take these terms over here, so from here I will get, therefore I will get A plus B the whole cube minus 3A square B minus 3AB square is equal to A cube plus B cube. So either of these one we are going to use, the one which is going to give us a much proper answer, that will use. So I think so this is going to help me, because this A and B are nothing but sin square and cos square. Okay. So I can substitute instead of A cube plus B cube. Therefore, sin raised to 6x plus cos raised to 6x, which I have written as a cube plus b cube, can also be written. I am writing this. It can be written as a plus b the whole cube minus 3 I will take common. So what will 3ab I will take common. So what will remain there is a plus what there will remain will be b. Okay, 3ab I have taken common. So now I will resubstitute the values of a and b. So a I have taken as sin square, b I have taken as cos square. So here when I put this will become sin square x plus cos square x the whole cube minus 3ab, so minus 3 sin square x into cos square x into a plus b, so a plus b will be again sin square x plus cos square x. So we know by identity sin square x plus cos square x is equal to 1, which implies that sin raised to 6x plus cos raised to 6x is nothing but equal to this value will be 1, so that will be 1 cube minus 3 sin square x into cos square x, sin square x plus cos square x is 1. So 1 cube is 1 only, therefore I'll get 1 minus 3 sin square x into cos square x. So this is the value of this term. Okay, I have found out the value of this term. Then this is also somewhat complex. So sin x minus cos x the whole raised to 4 can be written as sin x minus cos x the whole square raised to whole square. So 2 is into 2 is 4. So raised to 4 I have written something like this. An advantage of this will be sin. So when I expand this, I will get sin square x plus cos square x minus 2 times sin x into cos x, and this square that is the whole square. So sin square x plus cos square x is again 1. So this will become 1 minus, and with this formula, 2 times sin x into cos x is sin 2x. So this will be 1 minus sin 2x the whole square. Okay, so now let's substitute the values instead of this. So I'll substitute the values in the given question. So I'll get 3 into, instead of sin x minus cos x the whole raised to 4, I can write 1 minus sin 2x the whole square plus 6 into sin x plus cos x the whole square plus 4. Okay, instead of sin raised to 6x plus cos raised to 6x, this value we have found out to be 1 minus 3 sin square x into cos square x. So now let us simplify this. So I'll get 3 into, let us expand this. So I'll get 1 minus 2 times sin 2x plus sin square 2x plus 6 into, I'll expand this. So this will be sin square x plus cos square x plus 2 sin 2x. This 4 I'll multiply inside, so I'll get 4 minus 12, 4 into 3 that is 12 minus 12 sin square x into cos square x. This 3 I'll multiply inside, so I'll get 12 I'll get 3 minus 6 sine 2x plus 3 sine square 2x. This sine square x plus cos square x, that is 1. So 1 into 6, that will give me 6 plus this 6 into 2, that is 12. So that will be 12 sine 2x plus 4 minus this 12, okay, can be written as 6 into, or it can be written as 4 into 3. So 3 into this 4 into sin x into cos x, okay, the whole square. So this 4 can be further written as, okay, so this is how I can write. Please take this screenshot up till here. The space on the board is over. I will require the space. Take the screenshot up till here. See the solution properly. Try to understand it. It is little bit complex. Taken the screenshot. I hope everyone is taking the screenshot. So I'll further solve it. So I have here 3 plus 6, that is 9, plus 4, that is 13. So 3 plus 6, 9, 9 plus 4, 13. So I get it to 13. Then here I have minus 6 sine 2x, and here I have plus 12 sine 2x. So 12 minus 6, that will be 6. I get plus 6 sine 2x. Then here this is 3 sine square 2x. Sorry. That is 3 sine square 2x. And here minus 3. Okay, sin x, 2 sin x into cos x, that is sine 2x. So that is sine square 2x. So this plus and this gets cancelled. Yet somewhere I made some mistake, I guess. Yes, sorry, here I made mistake. This will be 2 times sin x into cos x. This, when I expand sin x plus cos x, I will get 2 times sin x into cos x, which can be written as sin 2x. So when the 6 gets multiplied over here, this will be plus 6 sin 2x. So this minus and here are this plus sin 2x. So this plus sin 2x and this minus sin 2x gets cancelled. Similarly, plus sin square x minus sin square 2x gets cancelled. Okay, this minus sin or minus 6 sin 2x and this is plus sin 2x getting cancelled. So I get answer as 13. So my answer is option number C. He has given us an equation and he wanted to find out an answer, and we have got option number C as the answer. Take the screenshot and go through the solution once again. If you have any doubt, then ask me. Gone through the solution. I hope everyone has gone through the solution. You don't have any problems with the solution. Let's go to the next question. Okay, next question, the value of the expression, the value of the expression root 3 cos sec of 20 degree minus sec of 20 degree is equal to option number A 2, option number B 2 sin of 20 degree upon sin of 40 degree, option number C 4, option number D 4 into sin of 20 degree upon sin of 40 degree. So let's try this out. If we see, either we are getting some concrete answer, that is 2 and 4, or if we are getting everything in terms of sign. So you have to convert everything in terms of sign. So that root 3 also should be written something. So if we go in the context of sine and cos theta, we don't have this value root 3. But if I go in tan theta and cos theta, then I get the value root 3. Tan of 60 degree. Right? Tan of 60 degree is how much? Root 3. Then let me consider this. Root 3 cosec of 20 degree minus sec of 20 degree. So root 3 can be written as tan of 60 degree cosec of 20 degree minus sec of 20 degree. The very first thing I'm going to do is I'm going to convert everything in terms of sine and cos, because the option is in terms of sine or it is some concrete answer. So it's better converting everything in sine and cos. So tan of 60 degree can be written as sine 60 into cos of upon cos of 60 degree. Cosec can be written as 1 by sine, so this will be 1 by sine of 20 degree minus sec of 20 degrees. Sec is 1 upon cos, so it can be written as cos of 20 degree. Next, if I try to equalize the denominator, okay, what I'm going to do is I'm going to equalize the denominator. Here I have seen the sin 20, here I have only cos of 20, so here I have multiplied divided by cos of 20. Sin 60 degree into cos of 20 degree minus. Here I multiply this entire term, multiply and divide by this entire term, so I get cos of 60 degree into sine of 20 degree. The whole upon, so my denominator will become cos of 60 degree into sine of 20 degree into cos of 20 degree. Now sin x into cos y minus cos x into sin y. If I consider 60 degree is x and 20 degree is y. So this is x and this is y. So sin x into cos y minus cos x into sin y is expansion of sin of x minus y. So this is an expansion of sin of x minus y. So x is 60 degree and y is 20 degree. And here I have cos of 60 degree into sine of 20 degree into cos of 20 degree. So now sine of 60 minus 20 is how much? 40. So this will become sine of 40 degree. So here if I see sine 20 cos 20, 2 times sin x into cos x is sine 2x, and therefore what I will do is I will multiply and divide by 2. So that is sine of 20 degree into cos of 20 degree. Into this term is there cos of 60 degree. So 2 times sin x into cos x is sine 2x. So sine or 20 into 2, that will give me 40 degree. So this becomes sine of 40 degree upon 1 by 2 into this. 2 times sine 20 into cos 40, that will become sine of 40 degree into cos of 60 degree. So this sine 40 gets cancelled. This 2 goes up. The 2 will go up upon cos of 60 degree. So I get 2 upon cos of 60 degrees how much? 1 by 2. This 2 will go up and it will give me 4. And getting the answer for which is option number C. So option number C is my answer. Take the screenshot. Okay, let's go to next numerical. Let's go for the next. So this is easy and quite conceptual also, and very easy. So tan of theta is equal to minus 4 by 3. Then sine of theta is option number A, minus 4 by 5, but not 4 by 5. Option number B, minus 4 by 5 or plus 4 by 5. Option number C, 4 by 5, but not minus 4 by 5. And option number D, none. This is a simple one. You can do it by your 10th standard method. It's not difficult. So try to understand tan of theta is minus 4 by 3. And which means your tan of theta is negative. So in which quadrant tan of theta is negative? In first quadrant all are positive. In second quadrant tan is negative. In third quadrant tan is positive, and fourth quadrant again tan is negative. If you have value of tan as negative, it implies that theta lies in second quadrant or it lies in fourth quadrant. These are the only two quadrants in which my tan of theta is negative. In first quadrant also it is positive, in third quadrant also it is positive. It is negative only in second and fourth quadrant. So my theta lies in second and fourth quadrant. This implies sin of theta. In second quadrant, sin of theta is positive. In second quadrant, and my sin of theta is negative in fourth quadrant. Because my theta lies in second quadrant and or in fourth quadrant, then I will have to check the values only in second quadrant and fourth quadrant. Which means my sin theta can have a positive value and my sin theta can also have a negative value. Because the theta lies in second quadrant where my sin is positive, or the theta lies in the fourth quadrant where my sin is negative. This implies that my sin of theta can be positive or negative. Okay, now let's try to find out the value. So tan of theta is 4 by 3 by definition it is opposite by adjacent is opposite is 4 and adjacent is 3. So if I draw the triangle, okay, opposite is 4, so this is 4 and adjacent is 3. This is my hypotenuse. By Pythagoras theorem, my hypotenuse square will be nothing but 4 square plus 3 square, so that is 16 plus 9, so that is 25. Therefore, my hypotenuse will be square root of 25, that is 5. So, my sine of theta is opposite upon hypotenuse, so it can be 4 upon 5 when it is positive. At the same time, it can also be minus 4 by 5 if the theta is in the fourth quadrant. If the theta is in second quadrant, then my sine of theta will be 4 by 5. And if my theta is in fourth quadrant, then my sine of theta will be minus 4 by 5. Hence, the option is option number B. Therefore, my sine of theta will be 4 by 5 or it can be minus 4 by 5. Okay, option A is okay, wrong, and option C is also wrong. Option A says that my sine theta can be minus 4 by 5, but it cannot take the value plus 4 by 5. Whereas my option C says that my sine theta can take the value of 4 by 5, but it cannot take the negative value. But we are clearly getting over here. Okay, we are clearly getting that my sine theta can be positive also and negative also because theta is in second quadrant or in fourth quadrant. Hence, it is option number B. Okay, it is simple and only a conceptual one. Hope you have understood. Take the screenshot of this. Take the screenshot. I hope you have understood this. Okay, now only some 5-10 minutes are left and that I will not be able to complete. I will not be able to complete the next numerical in this time. And therefore, we'll end our lecture here today. In the next week, I am going to come over there. So we'll start from where we have stopped. So this is the point where we have stopped. In the next class, we'll start from there. Okay? Have a nice day ahead.